Hello everyone. Thank you all for coming. We have a wonderful session for you. And so let's dive right in. So let me introduce Ali first. So Ali, thank you for joining us. So Ali's been investing in the crypto space now for many years. Before Ali started working in crypto, he worked on AI at Google Brain. And before Google Brain, he was at Stanford. So welcome Ali. And let's dive right in. So Ali, these days, stable coins are like super hot. Everybody talks about stable coins. Everybody wants to have a stable coin. So can you explain a little bit about why are they so exciting? What's so hot about them?
Yeah, of course. I think in some ways, stable coins are the first thing from crypto to actually reach product market fit in a way that you can point at and say like, okay, that's clearly working. I mean, some of the numbers, there's $33 trillion in stablecoin volume in the last 12 months, which is 3x that of Visa. We now are able, thanks to like blockchains like Solana or Base plus Ethereum, send any amount of money from anywhere in the world to anywhere else in the world in under 1 penny and under 1 cent, which is sort of categorically much, much better than any other alternative to be able to send money around. The level of integration and the level of adoption that we're starting to see from traditional financial institutions is pretty unprecedented. And I think one of the most interesting things is to see that the stablecoin volume is completely uncorrelated from crypto trading spot volume, which is a strong sign that it's not just another sort of speculative mania. It's somewhat decoupled from the speculative cycles that crypto normally goes through. So all of these are signs that stablecoins are beginning to become like a real application for crypto that hopefully within the next 6 months might reach hundreds of millions of users, hopefully 1 billion users. And that as an industry, I think we can rally around as like the first thing within crypto that's starting to work. And I think that'll have implications for the rest of crypto, including AI. So we'll talk about that. And I think as for why is it that they're finally beginning to work? There are two broad reasons that I think are likely to that we can likely point to. One of them is the regulatory clarity that we are now beginning to have around crypto, in particular the fact that it's likely we're going to have a stablecoin bill passed fairly soon, as well as a market structure bill that will help traditional financial institutions get comfortable with getting involved in crypto. And I think as they get involved, that'll have a big legitimizing effect on the rest of the space. So that's one reason. The other reason is that the infrastructure has finally matured, again, to the point at which we can send an arbitrary amount of money for under a penny in under 1 second. And so those two combined, like the product from a technical standpoint is finally there, and we've got regulatory clarity, have come together to lead us to this moment. And it's exciting to see how stablecoins are finally beginning to land.
So it's likely that like maybe in the coming years, like the general public will start using stable coins. Maybe we'll use them to buy groceries or whatever. But definitely there seems to be good product market fit. And I actually, just to echo what you said, it seems like there's also global adoption of stable coins. Where in developing economies, they're very popular. I guess people want to have dollars, and stable coins is a way for folks to have that. So it's a very, very, very good product market fit, also outside of the US.
Yeah, actually, like Patrick Collison in a podcast recently called stablecoins the equivalent of a room temperature superconductor, but for finance. And the reason he said that is that like the entire back end of a financial transaction becomes much, much more efficient when you can do it on blockchain rails, as opposed to having to go through like the issuing bank, the acquiring bank, the credit card network, all of whom take their own like little fee, their own pound of flesh, making for any transaction to be kind of like grossly inefficient. Whereas on a blockchain, it's sort of 1,000x better. So that leads to all sorts of new possibilities that were just not possible with the existing financial system.
So this is a panel about AI and crypto. So we kind of understand now why stablecoins are hot in general, but let's talk a bit about how are they going to be used in the AI space.
Yeah, and I think one of the reasons we wanted to start talking about stablecoins is that for any new technology, there tend to be two categories of use cases and applications. One category is doing the things that we already do, but doing them slightly better, doing them more efficiently, but it's effectively the same thing that we did before. It's just like faster, cheaper, etc. And then there's another category, which is the category of things that are net new, that we really couldn't have done before with the previous technology that the new technology unlocks. And so I think we often are just much more excited about the latter category, the net new things that become possible. And I think this is where the intersection of crypto and AI becomes pretty interesting, because if you make the ability to move money around 1,000x more efficient, 1,000 to 1,000,000x more efficient, especially if you're talking about international transfers, there's a good question of what all of a sudden becomes possible. And I think given that we now have this powerful, very compelling trend in AI of having agents be able to do all sorts of things, it's interesting to think about what they might be able to do if they can all of a sudden now be part of the financial system and send, say, hundreds, thousands, millions of transactions very, very efficiently and create an economy that's now actually primarily driven by AIs. So like one prediction is that in the next, say, 5 years, we're going to see that most of the financial transactions that happen in the world are almost entirely driven by agents as opposed to by humans. And that's the kind of thing that's not possible with our existing financial infrastructure, but all of a sudden is possible with things like stablecoins and blockchains. So that's kind of like one interesting way in which these things connect. And I think
but just a second, actually, I want to drill down into that just a bit more. So one could ask, and actually one should ask, is why, if we're going to have agents that have their own treasuries, and the treasuries are stored as stablecoins, and these agents basically manage their own stablecoins, why couldn't we do exactly the same thing with the TradFi system, with the traditional system? And an example would be maybe somebody sets up an MCP server that lets an agent talk to ACH and do transfers using TradFi. Why is it that stablecoins are so much better than having an agent talk to the bank directly?
Yeah, and I think this gets back to the fact that you do get qualitatively new use cases when you make something 1,000x more efficient. It's not just quantitative. Like the improvement is not just quantitative, it's also qualitative. So I mean, even with ACH or with, like if you look at the numbers for financial transactions today, like an international bank transfer costs like tens of dollars and takes like 5 to 7 days to actually clear, or more in some cases. Even a domestic transaction, if it's like a credit card transaction at a cafe or something like that, is like $3, say, for a $100 transaction, where like you have, again, the issuing bank, the acquiring bank, the credit card network, the point of sale, or the payment service provider, all taking a fee. So those numbers are just kind of unacceptable in the age of the internet, where like moving information is effectively free. Like being able to send a packet like of information from one computer to another is virtually free. It should really be that efficient to move money around. And so if it does actually become that much more efficient, then you can imagine AIs paying one another and doing micropayments that are extremely small at a very, very high frequency that simply just wouldn't be viable on the traditional financial system with ACH or with whatever bank transfers or any of these solutions that exist already. It'd be both too expensive and too slow. So that's one reason. And then the second reason is KYC and like the fact that the existing traditional the financial system is very oriented towards humans. And so the only way that you can use the financial system today is by having a human actually be the representative of the transaction. So for an AI agent to be able to transact using ACH, you basically have to have a human who's going to be the stand-in for the agent, for that agent to actually transact. And that is a fairly constraining limitation, especially when you're talking about transactions that could be global, where like maybe there aren't good standards for KYC in some of the countries where people want to participate or where agents may want to participate. So crypto is inherently global in nature. It's internet native. It has all of the advantages that the internet stack gives you, and it's not constrained by kind of some of these legacy requirements that the traditional financial system has.
So kind of just to summarize, so stable coins are a good match for AI agents. Let's see, because first of all, they are global, so you can send money from anywhere to anywhere. They're fast, right? So sub-second finality times, and they don't require specific KYC, which agents can't have. Yeah, exactly. At least today, agents can't have KYC, so the agents can be autonomous. Those are kind of the three reasons why stable coins are a good match for these agents. So what could go wrong?
Well, this is actually a great question for you. Like we've spent a ton of time talking about sort of some of the security considerations that come into this. If we are, as we kind of increasingly delegate our actions and we increasingly rely on AI agents, security becomes ever more important. And this is something that you've
we actually work on that a lot. I think it's a really interesting emerging field. So there's a lot of people who work, of course, on showing positive applications of AI. But then there's also a question of how secure are these AI systems? You know, how easy is it to confuse an LLM? How easy is it to confuse to confuse an agent? And unfortunately, even though these systems they perform really well on sort of random, benign inputs, there's this whole field called adversarial machine learning that shows that on adversarial examples, these models actually perform quite badly. They can be quite easily confused. So let me give you an example where you should be a little careful in using an agent. And again, this is something that I think the public isn't quite aware of. So hopefully you guys can all help raise awareness of this. So let me give you one example. So imagine you train an agent or some LLM to help you, just give you investment advice. So it'll go and read a bunch of quarterly reports. It'll read about a bunch of SEC filings. It'll read news reports, and then it'll generate some investment advice for you. Yeah, sounds like an interesting way of using agents for this. Well, it turns out it's not that difficult to formulate a quarterly report so that to the human, it looks like a normal report. You read it, it looks perfectly fine, like a normal quarterly report. But then all of a sudden in the report, there's a few words that are off, and there are maybe a few symbols that we would just ignore. But when an agent parses this report, these symbols are inserted adversarially, and they cause the agent to be completely confused. Yeah, and as a result, it starts taking actions that it's not supposed to do. So things that might be harmful to whoever's running it, and so on. So like a classic example would be like in the workplace. Maybe you ask an agent, here is our meeting notes from a meeting that we just had. Please send to-do items for all the members, all the people who were at the meeting. If the meeting notes actually has one of these adversarial inputs in it, the model gets completely confused and it starts sending emails to the wrong people, putting wrong content in those emails. And these are all examples. There are many papers that demonstrate this fact. Yeah. So when you combine adversarial examples, or more generally secure AI with agents that now have a treasury and can manage their own funds, things get interesting. And so this is clearly coming. This is clearly going to happen. All we're trying to do here is basically say we also have to think about the security angles of this and whether we can build robust models that are much harder to confuse and fool than we have today. Currently, this is an open problem. Somehow we humans are fairly robust. The agents that we have today are not as robust, but this is probably something that's going to get solved over time. Yeah. So good. I think it was important to talk about the security aspect of AI. So don't just jump on the bandwagon without. You have to have your eyes open as you do that.
Well, I think, and especially because a big part of the crypto space likes to talk about building autonomous systems. Like in some ways, blockchains are autonomous systems that run themselves. They execute themselves free of interference from humans, including the humans who originally built those systems. And so now, if we actually take the word autonomous more literally, and we begin to embed AI into these systems, if we actually, for example, build DAOs, decentralized autonomous organizations, where the autonomous actually is the most important word, then these considerations become extremely important. Because if you're going to actually trust a system that has autonomy and is actually censorship resistant and free of interference from the humans that built those systems, and if there is a component that is controlled by AI, then we have to be certain both that the AI is actually running the way that it was written, that the right code is running, and maybe that's something that we can touch on a bit, as well as that the AI itself, like the logic of the AI, can't be fooled or attacked in any of the ways that Dan has been describing.
Yeah.
Do you want to talk a little bit about sort of the role of TEs and how we're like building things that are more secure?
Yeah. So for these models, it's really important that the models are robust. They can't be confused. And as Ali is saying, that the model is actually running correctly, right? If you're trusting a remote server to run the model for you, how do you know this remote server is actually running the model correctly? And so there's an answer to this. There's a technology to this. Do you want to talk about this? Or?
Oh, go for it.
Oh, yeah. So there's a technology that allows us to do this. And maybe some of you notice this is what's called a trusted execution environment. Sometimes it goes by the name of enclaves. Intel has some technology that does it. Amazon has some technology that does this. So it allows you to basically run a model inside of an enclave in such a way that the results are actually signed by the enclave, and whoever is consuming those results is guaranteed that the model ran correctly. Yeah, so again, we just want you to be aware that this technology exists. You can demand that your models actually run inside of a trusted execution environment, so you can actually trust the results that come out of the model. Yeah, that the model ran correctly. So there, again, there are two issues here, right? Did the model run correctly, which we can solve using trusted execution environments, and is the model giving you good advice, or is it fooled because of these adversarial examples? This is something that we don't quite know how to solve yet, but hopefully we'll figure it out in the coming years. But I want to zoom out just a little bit. So we're talking about crypto and AI in this panel. And so I want to go back to more applications of blockchains to AI. Mm-hmm. So Ali, do you have more examples in mind?
Yeah, I think another really good example is proof of humanity. So there's an important project in the space I'm sure many people are familiar with called World, where they built a technology that is able to verify that a person is actually human. And the way that it works is that they built this orb that some set of people may buy, and then they can go out into the world with this orb and verify humans and give them a little bit of data that they can use to prove that they're human. This orb has biometric sensors. So you look into it and it scans your iris. It uses zero knowledge proof so that none of your biometric data ever leaves the orb and is destroyed immediately after. And it generates an attestation that you can then carry on your phone that is a proof of your humanity. And this is nice because now, again, you're not relying on some government to give you a government ID, which would be kind of limited to just that one particular jurisdiction. It's like fully cryptographic and like internet native in all of the ways you would want to be able to kind of electronically attest to your humanity. And it I think will unlock all sorts of interesting possibilities where you really want on the internet, when building services or when interacting with services, to know that the people you're interacting with are also human beings, especially now in a world where AI is going to make it quite hard to know if the entity you're interacting with on the other side is human or not. In the 90s, there was this expression that on the internet, nobody knows you're a dog. That expression is really, I think, very, very valid now, where like truly on the internet, nobody knows that you're a bot. It's actually quite difficult to know. AI has essentially passed the Turing test and can pretend to be human very effectively. So some of the use cases for this, like if you're on a dating app, for example, you'd want to know that the person you're talking to is human. If you're on a social network and you're building a community, there are cases where you really would want the community you're building to consist of only humans. And so I think this is one example in which crypto is a strong counterweight for AI, where like AI is leading to this kind of infinite creation of media, lots of which might actually feel and look like it's derived from humans. And crypto can help you maintain provenance or maintain some insight as to how that data is actually connected to where it was created, to the humans that were involved in creating it, or to wherever it came from, which I think will be an important part of how this plays out.
I can't resist, and I have to talk about one technical nugget in WorldCoin, which is this orb that scans you and gives you a proof of humanity. There's a really, really cool problem there, which, like Ali said, they scan your iris, but then they don't store the scan. So how do they know that you are not scanning yourself multiple times and now you're getting multiple proofs of humanity just based on your identity? And so there's they figured out a very, very clever technique in which they can prevent you from, they know that they can identify you if you scan yourself multiple times without actually storing anything about your iris. So it's actually really cool. I encourage you all to go read about how that works. But that's kind of a really, really cool aspect of the project.
Yeah, because one objective that WorldCoin has is to be able to allow you to prove that you're human, but disallow you from proving or from pretending to be multiple humans. So not only does it want to prevent an AI to pretend to be human, but it also wants to prevent humans from pretending to be multiple humans. So you have a unique proof of humanity, and you can only really do it once
without storing your iris signature.
Which is a hugely challenging technical problem, and the fact that they've solved it is very compelling.
So that's a pretty cool application. That's a application at the intersection of AI and crypto. Prove that you're a human. But we have many other examples at the intersection of AI and crypto. So does anything else come to mind?
Yeah, I mean, actually, backstage we were just talking about this company called Yup, or the company name is Bear Sarai. The product is called Yup with 2 P's. It's a new company. It was started by Pankaj who was at Coinbase and at Google. And the thinking behind this company is that you can use human contributions to determine the quality of an AI model. And so the way that it works, they have an app, and the app will show you the output of 2 AI models for a particular query or prompt, and then you as a human can pick which one you like more. Like if you like one more over the other, you can pick it, and then there's like an incentive system where you get rewarded for contributing back. And it could create this kind of marketplace where on one side you've got people on the AI side, like companies that are building AI systems who want to improve their models, using Yup as a way of getting feedback on how good their model is. And then on the other side, you've got just people like consumers, users out there who are willing to contribute and help in exchange for some reward. So it's an interesting way of kind of connecting these two worlds. Use crypto incentives as a way of improving the performance of AI models.
So the blockchain is used to track basically who contributed to comparing between different AI models, and then AI models, of course, give you the answers to what you want. Yeah, actually, I played with it, and it's really kind of a fun. It's a kind of a fun. You almost can treat it as a game where you ask a question like, "Why is the sky blue?" and then 2 answers appear, and then you're supposed to say which. So first of all, you get 2 answers, which is useful in its own right.
Yeah.
And then you're supposed to say like, which answer do you like more? And then you get kind of rewarded. So that's kind of a fun game to play with.
And then I think maybe the final application or the final intersection of the two spaces that we can explore in the last few minutes is maybe the most futuristic, which is to decentralize the infrastructure for AI itself. So there are a number of companies in the space, one of which is Jensen is in our portfolio, that is building a kind of marketplace for GPU compute. So you can think of it as a network, as a blockchain-based network, is decentralized, that acts as a marketplace where on one side you have people who have idle compute that they're not using, like for example, someone who has a GPU in their basement or a data center that has a rack that is not being used at the moment. Those people can contribute the compute to the network. And then on the other side, again, you might have an AI startup that's trying to train a model or do inference on an existing model. They can upload the model to the network and then have the compute execute on it. And so essentially, this would be a stand-in for using a cloud service like sort of like AWS or any of the other kind of hyperscaler clouds. It's a hard problem, but I think if we're able to crack it, it'll be possible to tap into all of the latent available computational power that normally isn't used. And again, crypto incentives play a huge role here because the incentive to contribute comes from a kind of blockchain-enabled reward for contributing your compute. And I think what's exciting about it too is that it might enable certain applications that you wouldn't be able to build on top of a cloud type native thing. Back to the whole idea that there's 2 categories of new applications. You can make just leasing compute better and more efficient. That's one category of something you could do with this. The other category is what is new that you could do on top of this that you couldn't do on top of a centralized cloud. And this is where, going back to the whole idea of building truly autonomous systems, if you want to have an AI agent that's truly autonomous, that actually isn't under the control of any one human individual or organization, then you're not going to be able to run that agent on a cloud because obviously whomever controls the hardware inside of the cloud controls the agent. Or could shut it down, even if it's in one of the trusted enclaves that Dan was talking about. So for those use cases, if you wanted to, for example, have an agent that is a kind of companion throughout all of your life, that has insight into everything about you, and follows you through life and is a kind of mentor and helps you out, helps you learn, is a kind of advisor, you probably wouldn't want that agent to be under the control of OpenAI or some of the other kind of big centralized monolithic tech companies. It'd be nice if there were a way for you to directly own it, for you to control the data that it's able to see and not see. And in order to do that, you need something like Jensen. It's a kind of decentralized substrate on which agents can run that isn't controlled by a cloud provider. That's very futuristic and hard because AI models are very difficult to run. They're kind of expensive computationally. So in order to decentralize that infrastructure, there's many open problems, but I think we believe it's a solvable problem, and it'll come with its trade-offs, but it's solvable to the point at which some of these applications will become real.
Yeah, and a technical nugget that they solved, which again you can look it up, is basically if I ask you to run a model on my behalf, how do I know that the answer you're giving me is correct?
Yep.
Yeah, and so there's lots of technologies that they developed in order to do that. Okay, so I think we are out of time. Thank you so much. This was a lot of fun. Thank you, Ali.
Thank you, Dan.
And
Appreciate it. Good
yeah,
to be here.
enjoy the rest of your day.